So here you have our spine tester. We have our indicator scale in the middle, and then we have two supporting members here that have ball bearing rollers. The distance from the inside edge of this roller to the inside edge of this roller should be approximately 28 inches. So we're going to go ahead and check that. And of course the indicator should be right in the middle at 14. So that is right at 28 and the pin is right at 14. When measuring the spine of the arrow, we have to come up with 880 grams worth of weight to hang from the center of the arrow. Well, part of that weight is going to be the weight of the indicator's pin, so we're going to weigh that so we can cancel that out of the total weight. Here we have about 20 grams worth of weight. When measuring the spine of an arrow, you must suspend an 880 gram weight from the center of the arrow. Well, we know that our indicator's pin weighs 20 grams, so the lead weight that we're going to hang, the total weight of that should be 860. 860 plus the weight of the pin will give us our 880. Let's see what we have. Right there, we're at 860 grams. The first measurement that we're going to take is going to be the weight of the arrow. So we're going to turn our scale on. Put the arrow in there. And for this particular arrow, we're coming up with 304.9 grains. The next measurement that we're going to record is the total indicated runout, or TIR. If the arrow is not straight, the indicator scale will show so when we rotate the arrow 360 degrees. So we're going to go ahead and start the rotation. And this arrow is showing slightly over 1/1000th of an inch of run out. So we will record that as 0.001 run out. Now it's time to measure the spine of the arrow in 4 different spots. So to aid us in doing this, we took a pin knock, and put it on the pin knock bushing, and we labeled it in 4 spots. There's 1, 2, 3, and 4. So we're going to install that into the end of the arrow, and then when it's sitting in the spine tester, we'll be able to rotate it and be somewhat accurate for the 0, 90, 180, and 270 degree spine recordings. Before we start to measure the spine of the arrow, first we have to set our 0 point of our scale. So what we do is we lift this up, lift up the pin, and visually note where it starts touching the carbon. That's about right there. So now I'm going to move the 0 to right there. I'm going to check it. Right there. Right there. And that'll be our starting point. You can see the weight of the indicator's pin actually deflects it about, in this case, about 12/1000ths of an inch. Now it's time to measure the spine at the 4 points of our arrow. So we already zeroed out our pin, so I'm going to hold the arrow at the number 1 mark, which is the knock standing straight up and down. I'm going to drop the weight on there and count the times it goes around. There's 100, 200, 300. And then I'm going to take my fingers and do a little tap to settle it. Right there, right about at 350 thousandths of an inch in deflection. So I'm going to record that. Now I'm going to lift the weight up, spin the arrow to the 2nd position, which is the 90 degrees in our recording. I'm going to drop the weight again. See, we have quite the difference here. That is 338 thousandths of an inch. Record that. Bring the arrow back up. And go to the third spot. Lower my weight. Yeah, 351 thousandths. And now for the fourth and final recording. .338 thousandths of an inch in deflection. So the recordings were for 0 degrees, it was 350, 90, 338, 180, 351, and 270, 338. So there's an example of recording the measurements from one arrow. And what we do is we then record it onto a piece of paper. We have the arrow's name right here, the date of the testing, and then the recorded measurements under each arrow. Now each arrow is going to have a mark on the arrow itself, being 1 through 12. And here are our spine recordings at 0, 90, 180, and 270. Total indicated runout. That is, for this last arrow, it was 0, and the total weight is 304.3. And then we also put down the advertised specs, which is this is a 350 arrow with the straightness being 0.001. And that's how we record our information on these arrows.